Hey everybody, welcome to Fun with Derivatives Part 1. So in this video we're going to explore all the different things you could do if you have derivatives. So finding a derivative should now be a walk in the park. I really hope so. In fact, in every problem we do in this video, you have to find the derivative. It's going to be needed. But I'm not going to actually walk through how to do all that work. I'm going to show it all, but it's going to kind of instantly appear on the screen. So you need to pause and review my work if you really want to know, hey, how the heck did he get that derivative? In past videos, I've described how to find derivatives. In this video, we're really focusing on what you can do after you have the derivative. So I'll show the work for finding the derivative, but it's on you to understand exactly what I did. All right, so what kind of fun problems can we do after we have found a derivative? Well, there's 4 of them. We're going to do 2 in this video entitled Fun with Derivatives Part 1, and we'll do the second 2 in the video entitled Fun with Derivatives Part 2. So in this video, we're going to focus on finding the slope or rate of change at a given point on the function, which is of course what a derivative was invented to do, right? A derivative's sole purpose in life is to give you the slope, aka rate of change, at a given point on the function. So we're going to definitely make sure we practice doing that. The second thing we're going to do is actually find the equation of that tangent line. So we're not only talking about the slope, well, the slope is the slope of a line. So once you find the slope of that at that given point, you could then find the actual equation of the tangent line at that given point as well. And then in the next video, we'll work on part 3 and part 4, which we'll talk more about again in that next video. But let's make sure we have a nice visual representation of what's going on here. So first off, we have a beautiful graph. Let's just call this graph f of x, for lack of a better word, right? And we got to have a point that is on that function. So right there is that point. And of course, that point contains an x value. And that is, of course, this x value right down here. Now, let's make sure we understand what a function does. A function's purpose is for you to plug an x into the function, and out you get y. So here we go. If I plug in x, I get y. But remember, again, these are interchangeable, right? F of x and y are the same thing. So once again, I could also look at this point as x, comma, f of x. Same thing as y. But the point is, no pun there, is that when you plug in x to the function, you get the y coordinate of that function. But a derivative is designed that when you plug x into the function, you get the slope, or again, rate of change at that point. We call that the instantaneous rate of change at that point. Now, the cool thing is that these two x's are the same, right? We're not changing the x. So the same x that goes into the function that gives you y is the same x that goes into the derivative that gives you the slope at that point. So it's pretty cool that we have 2 different functions, the original function and the derivative, but each of them take the same input, x, but what they give you out is something very, very different. All right, so let's get right to one of our problems. So here we're going to just find the slope of the tangent line when x equals 4 on the function below. So we have this function 2x cubed plus 4x minus 5, and we want to go ahead and find the slope of the line that is tangent to this function when x equals 4. But of course, the first thing we need is the derivative. So what is the derivative of this function? Well, I'm about to show you. And there it is, 6x squared plus 4. I basically had to use the power rule and the constant multiplier rule as well as the constant rule. But hopefully you can follow my work to see how I got that derivative. All right, now remember, the derivative is literally a function that finds the slope at a given x value. So to find the slope when x equals 4, all I have to do is plug in 4 into the derivative. So that's 6 times 4 squared plus 4. And showing all my work, that's 6 times 16 plus 4. And if you need to grab a calculator, do not be embarrassed. 6 times 16 is 96. 96 plus 4 is 100. So we have a very, very, very steep line. The slope of the tangent line when x equals 4 is 100. Very, 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 very steep line at that point. But how easy was that? You literally just take the x value, plug it into the derivative. Whoops, sorry about that. All right, next problem. Find the rate of change, well, that's just another word for slope, when the function is at x equals -2. So once again, literally the exact same problem. The only difference is instead of using the word slope, we're using the word rate of change because they are interchangeable. So the rate of change of the slope at the point x equals -2. So the first thing we need to do is find the derivative. And voila, using the quotient rule, there's my derivative, 11 divided by 2x plus 3, quantity all squared. So again, hopefully you follow my work there. I'm not going to walk through it. Done that in previous videos. But the question is, how do I find the rate of change when x equals -2? Well, it's really simple. All I have to do is plug -2 into the derivative. So here I go. The derivative when x equals -2 is going to produce the slope of that at that point, or the rate of change. So that's 11 divided by 2 times -2 plus 3 squared. And I'm going to take my time here. 2 times -2 is -4. -4 plus 3 is -1 squared. That's going to be 11 over -1 squared is 1. So 11 over 1 is 11. So the slope of the tangent line, the rate of change of the tangent line when x equals -2 is 11. Easy, easy, easy. All right, let's move on to the second type of problem where, no, I take that back. I'm sorry. We're still just going to find the slope of the tangent line here. We're not going to move on to the second type, which is find the equation. We'll do that in a moment. I apologize. So here we're going to find the slope of the tangent line when x equals 4. Easy, right? But of course, we need to find the derivative. So let's go ahead and find the derivative very, very quickly. And voila, there's the derivative of this function, 3, all divided by 2 times the square root of 3x minus 5. Now, what did I do to get that derivative? Well, first I rewrote the function as instead of a square root, I wrote it as a 1/2 power, and then I utilized the chain rule and then did a little bit cleaning up. Hopefully you follow that work. Now I want to find the slope of the tangent line when x equals 4. So of course, all I have to do is plug 4 into the derivative. 3 divided by 2 times the square root of 3 times 4 minus 5. Let's walk through that here. Let's see, 3 times 4 is 12. 12 minus 5 is 7. So I got 3 divided by 2 radical 7. So again, that in calculus is an okay answer. If you really want to get rid of the square root in the denominator, all you got to do is multiply top and bottom by the square root of 7, and you get 3 radical 7 over 14 if you would like. But I'm totally okay with this answer as the final answer for the slope of the tangent line, the rate of change when x equals positive 4. All right, next problem. Now here we're going to move on to that second type of problem in this video is actually find the equation of the tangent line. Not just finding the slope, but find the equation of that tangent line. So I actually have, so again, we want to find the equation of the tangent line at the point 1, 2 on the function x squared times the square root of x plus 3. So I actually made a graph of this in Desmos so we could take a look at it real quick. So here is the actual graph of this function, and I even plotted the point 1, 2. And again, I don't want to just find the rate of change of the slope at that point, which is what we were doing earlier. I actually now want to find the equation of the line that is going to be tangent at that point. So let's get back to it. Of course, to find the equation of a line, you need two things. You need a point. Well, hey, I already have a point halfway there, but you also need a slope, and that is what I do not know. And how do you find slope? The derivative. So of course, the next thing I'm going to do is find the derivative. Here I go. And there is the derivative, and it's a doozy, but the final derivative of this function is 5x squared plus 12x, all divided by 2 times the square root of x plus 3. I'll walk through this a little bit, but the first step was rewriting it as x squared times x plus 3 raised to the 1/2. That's what I did right here. Then I went ahead and used the product rule because I was essentially multiplying x squared times x plus 3 to the 1/2. But when I found the derivative of the back, I had to use the chain rule, and then created some fractions, went ahead and got a common denominator. A lot of good solid algebra work there that I hope you could do on your own at this point. But again, the answer is the 5x squared plus 12x, all divided by 2 times the square root of x plus 3. So now it's time for me to go ahead and find the slope. I already have my point. All I need now is the slope. So once again, I'm going to simply plug 1, my x value, into the derivative. So I have 5 times 1 squared plus 12 times 1, all divided by 2 times the square root of 1 plus 3. All right, let's see here. On top, I get 5 times 1, which is 5. 12 times 1 is 12. 5 plus 12 is 17. And the denominator 1 plus 3 is 4. Square root of 4 is 2. 2 times 2 is 4. So there's my slope, 17/4. I now know my slope. So now I can find the equation of that tangent line. And that is, of course, going to be very simple to find. I'm just going to leave it in point slope form. Y minus the y coordinate of 2 equals the slope of 17/4 times x minus 1, the x coordinate. And the cool thing about Desmos is, like I already showed you a moment ago, there is the function, there is the point, and now I can actually type that equation in. Y minus 2 equals 17 times x minus 1, and I could visualize and I could actually see that it is correct. I did find that green tangent line, and it is perfectly tangent at that point, 1, 2, to the function x squared square root of x plus 3. Pretty cool problem. The derivative is definitely a doozy, but once you get past that, actually finding the equation of that tangent line is very, very simple. All right, let's do one more of that type. Here we're going to find the equation of the tangent line to the function below at the point 1/2 comma radical 2 over 2. All right, so now, of course, first step, got to find the derivative of this function. So here I go. And voila, there's the derivative. The derivative of this function is 6 pi x times cosine of 3 pi x squared. Definitely had to do a little of the chain rule there for sure. Hopefully you followed through with that one. The derivative of cosine, or excuse me, the derivative of sine is cosine. Leave the inside alone, 3 pi x squared. And then I have to multiply by the derivative of the inside, which is 6 pi x. All right, now that's the tough part, but the easy part now is saying, all right, what do I need to find the equation of a line? Well, I need a point. I already got that. That's easy. Second thing I need is a slope. Well, how do you find the slope? Well, all you got to do is plug the x value into the derivative. So plugging 1/2 into the derivative, 6 times pi times 1/2 times cosine of 3 times pi times 1/2 squared. A lot going on here, but just take your time. So let's walk through this. 6 times pi times 1/2 is 3 pi. 6 times 1/2 is 3 pi. Times cosine, now be careful here, 1/2 needs to be squared first, so 1/2 is 1/4 after you square it. So then we have 3 pi over 4. 3 pi times 1/4 is 3 pi over 4. And that's one, you know, I would actually expect you to be able to figure out very, very quickly without too much effort. Cosine of 3 pi over 4 is negative radical 2 over 2. So the slope of my tangent line at the point 1/2 comma radical 2 over 2 is kind of an ugly slope, but it is what it is. It is negative 3 pi radical 2 all over 2. I just moved that negative one, or the negative, to the front. That's okay. So it's kind of an ugly slope, but it is what it is. And again, this is why we actually encourage that you just leave your final answer in point slope form and try to, don't try to make it harder than it needs to be. So the equation of the tangent line is going to be y minus the y coordinate of radical 2 over 2 equals the slope, as ugly as it is, negative 3 pi radical 2 over 2 times x minus the x coordinate of 1/2. And there is your equation of the tangent line. Now I also do want to show you this one in Desmos as well. It's actually a really ugly function. So the original function I have in there, sine of 3 pi x squared, it's kind of a cool looking sinoid function there. And I graphed the point 1/2 comma radical 2 over 2. You can clearly see that point right here is on the function. And then I also graphed my final answer, which is the red line that is tangent to the function at that point. It is set, and you can even zoom in, really nice to see that is definitely tangent to the function at that point 1/2 comma radical 2 over 2. Pretty cool. So that's it, guys. So again, what's going to hold you back in this new lesson on fun with derivatives is if you can't find derivatives, right? Because what you could do after you have a derivative is actually really, really easy. You could find a slope. All you got to do is plug in the x coordinate. Or the second thing you could do is actually find the equation of the line, which really doesn't require that much work because you already have a point. All you got to do now is find the slope using the derivative. So I kind of gave some tougher problems in this video just because I want to emphasize that you need to continually work on finding derivatives using all the different rules we found. So I know I didn't walk through all those problems in this video, but that's for you to kind of pause and see if you could follow through on your own in terms of how I got these derivatives. Because in almost every problem, there are some pretty good derivatives. All right, guys, hopefully you had some fun with derivatives and you now know how to do two things once a derivative is found. Find the slope or rate of change at a given value on the function, or find the equation of the tangent line to a function at a given point, as we saw in this final problem. All right, guys, that's it. Hope you enjoyed it. See you soon.